In section 3.1, we're going to discuss measures of center. There are several measures of center, and we're going to look at all of them, and we're also going to talk about when it is appropriate to use each of those measures. So let's get started with the mean. The mean is simply the average of a set of data. To find the mean, we're going to add all of the data values together and then divide by the number of data values. Whenever you see the variable n, lowercase, that is what n refers to, is the number of data values. So you might see something like the sum of xi divided by n equals mu. That's just fancy math talk for find the sum of all of the data values, divide it by n, and that's going to give you your mean. So let's take a look at how we would do this. If I add 5, 6, 8, 10, 4, 6, and 9, and divide it by 1, 2, 3, 4, 5, 6, 7, that's going to give me 48 divided by 7. Now, one thing I want to point out, because obviously this is pretty simple math, and yet a lot of people do not get the correct response when they're finding the mean, because if you're putting this into your calculator and you type in 5 plus 6 plus 8 plus 10 plus 4 plus 6 plus 9 divided by 7, your calculator uses the order of operations and will take 9 divided by 7 and then add that to the rest of those values. So if you're going to use your calculator for this, which of course you are welcome to do, please make sure you're using the parenthesis. We're also going to use Excel for this, but for now, we're just looking at this by hand. So again, 48 divided by 7 gives me my final answer, 6.8571. So that is the average number of hours of sleep per night. Sometimes we are given the average, but we are not given one of the data values. So for instance, let's say James has downloaded 5 apps to his phone. He knows that on average the apps cost $1.23. If 4 of the apps cost $1.29 each, what was the price of the 5th app he downloaded? So we're going to use that exact same formula, and instead of writing out 1.23 plus 1.23 4 times, I just said let's take 4 times 1.23 and add x. So that's a total in the numerator of 5 items. 4 at $1.23 and then x, which is my unknown. Now I'm just going to do the algebra. So that my first step then is to multiply by 5. Now when I multiply by 5, on the left side, my 5's go away. So that's going to give me, if I take 4 times $1.23, 516 plus x on the left side, and on the right side I've taken 129 times 5 to get 615. Now all I have to do to get x by itself is to subtract the $5.16 from each side, and when I do that I get my final result, and that final result is that x is 99, 0.99. Now, what exactly does that mean? Well, that means the 5th app that James downloaded was 99 cents. So why do I make such a big deal about that? Because so often in statistics, I see students take their time to find a correct response and then not really understand or convey that they understand what that means. So what does it mean? It means the 5th app costs 99 cents. Now let's look at a weighted mean. You've probably dealt with weighted means quite often throughout your educational career, and a weighted mean occurs when each data value doesn't carry the same significance or weight. So for instance, I'm sure that you have all read your syllabus and you know exactly how many points everything is worth. This is not a weighted class, and yet it is out of 1,000 points. So if I instead set the gradebook up as weights, these are the weights that would be used. 48% of your grade comes from homework, including the syllabus quiz, 24% from your chapter assessments, 16% from projects, and 12% from participation. Let's say your grades are that you earned 89% of homework, 76% of assessments, 95% in your projects, and 87% in participation. What grade do you end with in my course? Well, all we're going to do is take each of these of your grade values multiplied by its respective weight. So I'm going to take 89 times 48% and 76 times 24% and 95 times 16% and 87 times 12%. Now, because this added up to 1, which often will happen, I really didn't have to do this part on the bottom where I added those up. So in a weighted mean question, you would add those up unless you know that they add up to 100%. So again, I get 86.6%, which is a B. Now let's take a look at the median. The median is just our middle data value. If there are an odd number of values, or if you have an even number of values, you just have to average the two middle values. So again, what you want to do is be sure that you have your data from least to greatest. So let's do that first. So in my first example, I have 2, 3, 4, 6, 7, 8, 9. So finding the middle, I have 1, 2, 3, 4, 5, 6, 7 values. So I can either just count in from the inside and cross them off as I go and find that my solution is 6. The other way that you can do this is because the sum of the values, or n, is 7, I can take 7 divided by 2, it's always divided by 2, and get 3.5 and round that up to 4. And that means it's the fourth value. So 1, 2, 3, 4. Again, I can do the same thing for B. I can write them from least to greatest. So 1, 4, 5, 7, 8, 8, 9, 9. Now again, I can either count in from the inside and end up with two values, 7 and 8, and I would then take 7 plus 8 and divide it by 2, which is 15, divided by 2, which is 7.5, which is going to be my median. Or, just as I did before, if n was 8, I could say 8 divided by 2 is 4, so I'm going to take the fourth value, 1, 2, 3, 4, and the fifth value and average those. So either way, I end up with the same result. The last measure of center is the mode, and the mode is simply your most frequently occurring data value. So it could be that you have no mode, it could be that you have two modes, which is called bimodal, or several modes, which is called multimodal. So here is data for the number of phone calls received each hour during business hours for 4 different companies, and we're going to find the mode of each and state whether it's unimodal, bimodal, or neither. Looking at A, I can see that 6 has occurred twice, 7 has occurred 3 times, and that is the most frequently occurring, so the mode is 7. So it is unimodal because there's just one mode of 7. For example B, I have everything has occurred once, which means there is no mode. So therefore it's neither unimodal or bimodal. For example C, I have 2 2s, I have 1 3, 1 5, I have 2 7s. So I would actually have two modes here, 2 and 7. That would make it bimodal. And then for the last one, I've got 2 2s, 2 3s, 2 4s, 2 5s. So those are all considered modes and called multimodal. Let's take a look now at how to use Excel to calculate all of the values that we just calculated by hand. For our first example, we were looking at the number of hours of sleep, and I'm simply going to use the average function. Notice when I type out average and then I use the open parentheses, it then gives me the information here that I need to just include the numbers. So I'm going to select the entire array, and notice what happens in Excel is it says A1 and then a colon A7. So that tells Excel to go from A1 to A7. So I could have just typed that in as well, and then enter gives me the same mean that we found by hand. For our next example, we looked at finding a weighted mean. Now, there is no function in Excel for a weighted mean. However, if your denominator is 1, and our denominator here is 1 because all of the values for weights adds up to 1, then I can simply use the sum product function. And so I'm going to use equals sum product. And then when I open the parentheses, again, it says array 1, array 2. So what I need to do is array 1 is going to be all of the scores, and then comma, and then array 2 is going to be all of the weights. Now this is going to give me the correct answer, 86.6, which is what we had found by hand as well. Now if this sum was not 1, I could still use the sum product function to find the numerator, but then I would have to divide it by whatever the denominator is, which would be the sum of the weights. In our next example, we were looking at median, and to find the median, we're just going to use, the median function. So again, I'm just going to select it by hand, but I could also type in equals median and then type in myself that I have D2 colon D9. Either way, it's going to give me the same result. And notice I got the median of 6, which is what we had found by hand, and a median of 7.5, again by hand. For our last example, we were looking at the mode, and the mode can be found using equals mode, or equals mod, maybe. No, it's mode. And just be careful, because remember, this mode was 7. This mode was that there was no mode. Now, if I just used mode here, notice it's only going to give me 2. But if you'll recall, in this example, we had a mode of 2 and of 7. So instead of using mode, it's a better idea to use equals mode mult, and mode mult will give me the values that I'm looking for, so 2 and 7, which were the 2 answers. So I could use mode mult here as well, and if I do that, it's still just going to give me the 1 mode. So equals mode mult, and it finds all of those modes for me. Here's another example for us to work through. So I would like you to try this question on your own. Use Excel to find the mean, median, and mode. And then once I work through it with you, I'm also going to show you another way to calculate mean, median, and mode. When you're ready, press play to see how you did. So again, I'm looking just for the mean, median, and mode, and so I'm going to use equals average, and then select the array, equals median, and select the array, and equals mode mult, and select the array. So that is the mean, median, and mode. Pretty easy to find using Excel. The best part is I don't need to make sure everything is in the proper order as I do when I have to do it by hand. Now, sometimes you want to find just all of the descriptive statistics, including the mean, median, mode, and some of the other things that we're going to learn about as well. So what you need to do is you need to have the data analysis toolpack enabled. You know that you do if you click on data and you see data analysis. And if you don't, you need to go to File, Options, and then add-ins, and data analysis toolpack needs to be enabled. So I would go to Excel add-ins and then go to Go, and then make sure there's a checkbox next to Analysis Toolpack. So because I already have it, I'm just going to click on Data Analysis, and I'm looking for the descriptive statistics. So that's going to pop up this box and say input range, so I'm going to choose all of the values in my input range. Now, if I had a title here in A1, I would make sure that I checked labels in first row. Because I don't, I'm not going to check it. Notice I have columns checked because that is going to take the entire column. I could have also just selected column A. And then just as we did with pivot tables, you're going to choose your output. So I'm going to choose my output range to be this cell, this cell. And then I need to choose that I want the summary statistics and click OK. And notice it has found my mean, 75.25. It has found my median, 79.5, and found my mode of 80. So when is it appropriate to use the mean or the median or the mode? Which one is best? So all three are great and all three measure center, but they're not going to be the same value. So when we have qualitative data, remember that's a category. There are no numbers involved. Therefore, the only way that we could choose a center is the mode. So the mode is going to be used for qualitative data, and it's the most frequently occurring value. Now, what about the median? When is the median appropriate? When is the mean appropriate? Both of those are going to use quantitative data. The big difference between the two is outliers. So if you don't have an outlier, it's going to be different than you do have an outlier. So let's talk about why before we say which one is which. Let's say I have a distribution that looks like this. We've talked about the shape of distribution. This is skewed to the left. It's skewed to the left because the tail is on the left. So this is skewed left. Now, if I were to find the median and the mode, the median would be here somewhere. I'm sorry, the mean and the median. So the median would be there, and the mean is going to be a little bit to the left of that. Now, why is it to the left? Because the mean is the average, and the average is going to take into account this very low value, and that's going to bring the mean down a little bit. And therefore, it makes more sense when I'm dealing with skewed data, whether it's skewed right or skewed left, it doesn't matter. If I'm going to use that, I'm going to use the median. So if there are outliers, I should use the median. Now, if it's symmetric, great picture, I get it. Really, you're going to end up with the median and the mean being exactly the same or very close. And the mean is just a stronger value, and that's why we're going to use the mean if you're dealing with fairly symmetrical data with no outliers. So let's take a look at a practice question. Looking at these three, obviously one is going to have each of the three answers below. So for the first one, we have children's t-shirt sizes, small, medium, large, extra large. So this one hopefully is very easy. This is not numerical data, so it is not quantitative, it is qualitative. Therefore, we should be using the mode, the most frequently occurring. That leaves us with the two quantitative values for salaries for a professional team of basketball players and prices of homes in a subdivision of similar homes. So the big question should be, where can I expect to see an outlier? Well, if I'm looking at the prices of homes in a subdivision of similar homes, I'm guessing that all of those homes are going to be fairly similar to one another, not only in structure, but also in price. So I'm probably not going to have any outliers, so I'm going to use a mean here. However, If I'm looking at salaries for a professional team of basketball players, someone who is very famous and a high performer is going to get paid a lot more than your standard basketball player. Therefore, there will be outliers for those salaries, and we would want to use the median instead because those outliers would not be taken into effect. Now that we've explored measures of center, let's take a look at measures of spread or dispersion.